Balloon 6-4 layout to launch. Let's continuing with the pre-flight preparations. It's now appropriate to check the instruments. Since most instrument systems rely on battery power, it's wise to ensure that the batteries provide sufficient power to operate them. Nothing is more frustrating than discovering non-functional instruments when ready to fly. After confirming the instruments are operational, they can be mounted in the basket. Some pilots may choose to set the altimeter at this point, adjusting the barometric pressure according to the weather briefing. In the absence of a barometric pressure setting, the altimeter should be set to the appropriate field elevation. An exception to this is when flying from an ocean beach, where setting the altimeter to 0 is acceptable to avoid airspace issues. With the basket on its side and instruments mounted, the next step is to open the envelope bag. The crew should then remove the suspension cables and attachment hardware such as carabiners, A-blocks, or toggles. Following the manufacturer's instructions, attach the bottom of the envelope to the basket superstructure, ensuring that cables are untwisted and free of damage, kinks, loose wires, or missing sheathing. Once the envelope is securely attached, check the hardware for security before laying out the envelope for inflation. There are various ways to lay out a balloon, and the chosen method depends on factors such as the manufacturer's specifications, launch site surface, and the order of assembly. Two common methods for cold inflation preparation are spreading out the envelope or inflating it from a long strip. Before removing the envelope from its bag, the pilot should take a moment to walk around the launch site, checking for any debris that may damage the balloon. Caution is advised against dragging the envelope bag on the ground, as this could cause holes and tears. Instead, lift the bag clear of the ground unless the launch surface is free of sharp objects or debris. The spread layout method is widely used, involving handling the envelope with the load tapes to pull the fabric away from the center until the envelope takes its normal shape while still flat on the ground. Care must be taken to avoid causing damage while sliding the fabric across the ground. The even number of load tapes allows for proper positioning of the envelope for inflation. Crew members, one on each side of the envelope fabric, start at the mouth and travel the length of the load tape, pulling the fabric taut up to the equator. This allows the bottom to be laid out flat, and only load tapes should be handled to prevent damage. Checking the deflation system is also crucial at this point, and the crew can assist the inflation process by lifting upward on the load tapes. Alternatively, when inflating on pavement or a small launch site, the strip layout method involves pulling the envelope straight out from the basket and inflating it entirely with the fan. This method minimizes handling the fabric on a rough or dirty surface, but requires more diligence from the ground crew to ensure correct deployment. A variation is the progressive fill, where the envelope is cold, inflated directly out of the bag while being progressively pulled out as the fan runs. This method generally results in faster inflation, but may present challenges with attaching a parachute top or ensuring lines are not tangled. In determining the placement of the inflator fan, the choice between a large, powerful fan for the strip layout method or a less powerful one for the spread layout method depends on the amount of work required. Regardless of the layout technique, the general principle remains consistent. The fan should be positioned to the side of the basket, with the airflow directed into the mouth of the balloon to inflate the envelope. It should be far enough back to allow the airflow to seal the throat, optimizing the fan's efficiency. Pilots often use a practical method to find the optimal fan placement. Small pieces of fabric or surveying tape are attached to the lower portion of the mouth using safety pins. The crew then holds the balloon's mouth open with the fan running. If all pieces of tape point into the envelope, the fan is correctly placed. If any tapes flutter back out, it indicates that the airflow is not efficient and the fan should be adjusted for better inflation. This demonstration is conducted without using the burner to avoid unintentional damage or fire. Filling the balloon with cold air is generally preferred. This results in a tighter mouth, minimizing the risk of burning fabric. Additionally, a balloon filled with cold air may be less affected by light wind when it is round and tight. Ensuring safety during inflation, the quick release or safety restraint should be secured with little or no slack in the line to prevent potential damage or injury in case of a break or premature release. Proper tying off procedures, as specified in the balloon's flight manual, are crucial to avoid damage to baskets, suspensions, load plates, and burner supports, especially in light winds. The use of a safety restraint is recommended for enhanced safety. Before inflation, a pilot should provide passengers with their initial briefing regarding behavior during the flight and landing. Passengers are instructed to stand in the rear of the basket, facing the direction of flight, with feet and knees together, knees slightly bent and holding tightly to the sides of the basket during landing. They are not to exit the basket until instructed by the pilot. This procedure allows passengers to observe the landing sequence and is widely accepted in the ballooning community. In larger balloons with compartmentalized baskets, some pilots may encourage passengers to face away from the direction of flight. Regardless, the procedure should be briefed before flight and reiterated before landing. With the pre-flight preparation complete and excess equipment stowed, the balloon is ready for inflation and a radio check is conducted. The inflation procedure is a critical phase that transforms the balloon envelope from a pile of fabric into an aircraft ready for flight. The pilot aims for a smooth, controlled inflation that avoids damage to the environment, the balloon, and the crew. The desired outcome at the end of inflation is an upright balloon, close to equilibrium and prepared for flight. There are various styles of inflation, influenced by factors such as balloon size, available crew, weather, location, and personal preference. Some pilots use large fans for a fast inflation, while others prefer a slower filling process to allow for pre-flight preparation. Once the balloon is correctly laid out, the inflation fan is placed to the side of the basket within arm's reach of the pilot, facing into the center of the envelope mouth. Crew members are positioned at each side of the mouth to lift the material and create an opening for air to enter during cold inflation. The goal is to inflate the balloon as fully as possible with cold air, at least to approximately 75%. During this phase, the pilot checks control lines, ensures the correct deployment of deflation panels, and inspects the envelope for any damage that could disqualify it from flight. Once the pre-flight inspection and cold inflation are complete and the envelope contains enough ambient air, the crew members at the mouth hold it open wide and tall to keep the fabric away from the burner flame. The fan speed may be reduced, and the pilot lights the burner's pilot lights in preparation for inflation. Before activating the blast valve, the pilot ensures eye contact with each crew member at the mouth, confirming their readiness. The fan continues running until the balloon mouth lifts off the ground, ensuring that envelope air does not come back out. The first burner blast is short to confirm the correct flame direction and check the crew's readiness. Subsequent inflations may consist of a series of short burns and pauses to reduce crew discomfort, cool the fabric, and allow communication. The burn and pause routine continues until the balloon is nearly ready to leave the ground. The crew stands by the basket, ready to hold the balloon, preventing unintended liftoff. Achieving equilibrium or neutral buoyancy immediately after inflation is crucial to minimize susceptibility to wind and potential spinnaker effects. Loose equipment is secured, multiple tanks are managed appropriately, the burner is checked for leaks, altimeter settings are confirmed, radios are turned on and secured, and the fuel level is checked. This check, verified through a pre-launch checklist, ensures that the balloon is ready for a safe and efficient launch. Once the balloon is up and standing, if you have passengers, invite them into the basket. Compensate for the added weight by applying enough heat to regain equilibrium. Remind passengers of the landing procedure and brief them again on basket behavior. No touching control lines, secure personal belongings, stay within the basket, and follow the pilot in command's PIC instructions. Keep at least one crew member near the basket for assistance. Give the crew a final briefing on the expected flight details, radio channels, and any last-minute instructions. If other balloons are launching nearby, ensure the area is clear above. For a slow ascent, use 2 or 3 standard burns from equilibrium. If obstacles are absent, a slow ascent helps test wind direction and detect changes. Remember, the balloon below has the right of way. For a rapid ascent, instruct the crew to put weight on the basket, heat the balloon beyond equilibrium, and after checking for traffic, instruct the crew to remove their weight. Make sure the crew is clear to avoid an uncontrolled ascent. During launch, eliminate distractions and unintentional descents by addressing ground tasks beforehand. Be aware of false lift or unplanned descents caused by surface wind or ascent from a sheltered site. Identify obstacles like power lines early for a safe ascent. Consider phenomena like false lift, false heavy, or uncommanded buoyancy. Be cautious, avoid if possible, and understand procedures to minimize their impact. Factors like false lift, false heavy, and envelope distortion can affect control and require careful management.